In this video, I will be reviewing select problems from Chapter 5. So to start off, we started Chapter 5 with the mid-segment theorem. So first and foremost, the mid-segment connects two midpoints of a triangle. So on one side I have a midpoint, on another, and then it creates this segment. And what this theorem says is that, for example, this triangle, MP, which is my mid-segment, is equal to 1/2 of NO. So is equal to 1/2 of the base it's parallel to. So I'll just put the parallel base. Alright, so that means that x here is going to equal 8, and if I have this mid-segment, then this is going to be double. So that means this is going to be 14. Since it's a midpoint, on the side should be 4, and doubling 4.5, this should equal 9. So that's just a little review about mid-segment. We also know that it is parallel, so if I'm talking about GJ, what is the only line that does not intersect it and is parallel? So I'm going to ask for the whole side here, so DF. And then EJ, it says EJ right here is going to be congruent to, since this is a midpoint, it does say that EJ is congruent to JF. Alright, and so there's going to be JF right there. It is also congruent to its mid-segment that it's parallel to, and you can kind of see that these three pieces actually all look equal, so GK. Alright, and so that's going to be true for all three of the mid-segments, no matter whether it is, let me get a different color here, GJ with DK and KF. They're parallel and they are congruent. Alright, so I can do something like number 9 and 10 with a little bit more complex math, I guess. So UW, here's UW, it is 4x minus 1, and we are given YZ, which is the whole side, 5x plus 4. So right away we know that they're actually not equal. So look at UW, it's a lot smaller. But I do know that if I double UW, so I multiply it by 2, it is going to equal that whole side, because the mid-segment is half of the parallel base, the base it's parallel to. So then I multiply through, get 8x minus 2 using my distributive property. And I solve for x, so I want to subtract 5x. And I get 3x, and then I want to add 2 to both sides. I do that in one step. So that's 6. And x equals 2 once I divide by 3. Alright, so if my last question were to find YV, I would simply have to plug it in. Now I have this whole side here, so that doesn't give me YV, but if I substitute that in for x, these segments are congruent, so that should be able to give me YV. So 4 YV is going to equal UW, which equals 4 times 2 minus 1, so that's 8 minus 1. So that segment is 7. Alright, I'm going to move on to section 5.2. In section 5.2, we talked about perpendicular bisectors. So whether there's enough information and using it. So we do have in this picture the perpendicular part, and we do know that it bisects since those two segments are congruent. So by actually hypotenuse, leg, we know these two triangles are congruent. So we can set CD equal to DA. So 2x plus 4 is equal to 4x. Subtract 2x, 4 equals 2x, and divide by 2, x equals 2. So it wants us to find CD. So once I find that, I need to substitute it back in, and I get 2 times 2 plus 4, which equals 4 plus 4, or 8. So CD equals 8. That's my final answer. And you do something similar for all 2, 3, and 4. And of course you should have these homework answers. So looking at these perpendicular bisectors, it creates something called the circumcenter. So that is the point of concurrency for perpendicular bisectors. Alright, so what happens is I have all these perpendicular bisectors. There they are. And I draw them so that they all end up meeting at one point, and that's called the circumcenter. Once I find that point, if I connect it back to each vertex, I know that those 3 segments are actually all congruent. So if I were to find MO, I know it's congruent to ON. I'm even going to write that is congruent to ON. So I know that it is worth 26.8 units. And if I were to find PR, that's a midpoint right there because it's a bisector. It's a perpendicular bisector. So PR is equal to 26. And MN, zoomed out. If I were to find MN, since this is a midpoint, that's 20. MN, the whole thing is 40. Right? So that gives you a couple different things, segments that you might find. You also should keep in the back of your mind, since we do have a lot of right triangles, we might have to use our Pythagorean theorem at some point to find a side if it asks for it. So the circumcenter is for perpendicular bisectors, and just so that you can see it, I'm going to draw a circle around the whole triangle so that you can see what the circumcenter does. So with this circumcenter, we can actually create a circle that does touch all of the vertices. It's a little off, but you are able to see that each one of these congruent segments becomes a radius. So that's why they're equal. That's a circumcenter. The circumcenter goes, it's the point that's the center of a circle that can go around that triangle. So think of circumference. It goes around. In addition to knowing what a circumcenter is, which is the point of concurrency for perpendicular bisectors, we also need to know if there's enough information to say that it is a perpendicular bisector. Alright, so it says, is there enough information to allow us to conclude C is on the perpendicular bisector? So I would go look back and see what information you have. Here, for number 11, I do have the perpendicular and I have the bisector piece. So yes, this should definitely be, there is enough information. But what about the next problem? It certainly looks like there's not that much information. But we do know that C is equidistant, so in both cases C is equidistant, so since those AC is congruent to BC, it is going to fall on the perpendicular bisector. That's one of the converses of the theorem. So if it's equidistant from the endpoints of a segment, it should fall on the perpendicular bisector. So both of them actually have enough information. So I'm going to move on to section 5.3. In 5.3, we discussed angle bisectors. So angle bisectors, we need to definitely see congruent pieces of an angle, some right angles, because that means it's the distance. It is a distance if you see a right angle or an altitude. Or we need to see the right angle and a congruent leg. So what ends up happening is we can think back to last section. Either these are proving triangles congruent by angle, angle, side. Here's one angle, here's the other angle, and here's the shared side. Or we're using, it looks like side angle, but that's actually not a thing. This is hypotenuse leg. That's why we need to have the information that we do, so that we can set those two triangles congruent. So here, it asks for AD. So AD is just going to be 7, and ask for angle DBA, so that's 20 degrees. And we can even get a little bit more complicated by setting these equal. So finding the value of x that works. So you would set 10x plus 10 equals 8x plus 20. And, zooming out again. Then you subtract 8x, get 2x, and subtract 10, you get 10. X equals 5. Alright, so that's the value of x that works for number 3. For number 4, it's going to be very similar. And 5 and 6, this is asking, is DA congruent to DC? So do I have enough information to determine this? So here I do have the perpendicular piece and I've got the angle bisector piece. So I could use angle, angle, side to say they are congruent. So yes, this isn't enough. I can prove those triangles are congruent by angle, angle, side. We didn't really talk about that too much, but that's what we would use. Here, there's not enough information. All we have is that those two angles are congruent. We don't have another angle, we don't have the perpendicular piece, we don't have this side, or anything like that. So, not enough info. Alright, and can I conclude that BD is an angle bisector? So I need the perpendicular piece here, and I have that perpendicular, and I also have a congruent segment. Alright, here I just have a congruent segment, so that's good, but there's not enough information because I don't have the perpendicular piece. So it's just kind of thinking through what you need. You definitely need enough information and enough marks to use these theorems. If you don't have those perpendicular pieces or those marks like this one, I can't actually set those values equal. So make sure you look at it before you work through it. And the last piece of section 5.3 was the in-center. So if I were to look at a problem like this, the in-center means that I can draw a nice circle in the middle. And if you remember anything about circles, they don't look like that. A circle, you can see that all of these, PU, PQ, and PV, they become radii. So they're congruent. So we start out with angle bisectors. So those angles are cut in half, all three of them. And where they meet, where their bisectors meet, that's called the in-center. And then you can draw altitudes back to each side from there, and those become radii. They're all congruent. So if I erase my circle, we want to find x. So I know that these two triangles right here should be congruent. So this is 12. And in order to find x, I have a right triangle and a missing side. So I need to set up the Pythagorean theorem. So x squared plus 12 squared equals my hypotenuse squared. So that's 144, 169, and x squared. So x squared equals 25, and x equals 5. So, like I had talked about previously, we're given right triangles here. We might have to use the Pythagorean theorem. Or, in this case up here, it's just looking for ST. So, remember, those all become congruent radii, so this one's just nice and easy, and that's 15. Alright, I'm going to move on to section 5.5. And by 5.5, I mean 5.4. Alright, 5.4, we have medians and altitudes. So a median means that it connects a midpoint to the opposite vertex. So that means when I ask for AD, it's going to be 6, and this is going to be 17. We're going to skip the graphing one because we worked that out in class together. Alright, so copy and complete the statement when we are looking at medians. So it's going to be easiest if I work through these examples. Medians intersect at the centroid. So I've got circumcenter, incenter, and centroid. For this one I have medians, so these are midpoints, all of them. Alright, so just filling in some values I know already. That's going to be 6. Alright, so this is the one where you have a segment. This is my median, so let's pretend this is RU. This is RS and U. This is 4. So, we're going to work through a couple of these. This is 6. RV is 6, since that side it's a midpoint. SU. So, from the vertex, here's the vertex, to the centroid, is 2/3 of the total. So this is 2/3 of the total, and this is 1/3 of the total from the centroid to the midpoint. Alright, you can kind of see that this piece is smaller. SU is definitely smaller. So SU is going to be half of that, since it's 2/3 to 1/3. So this piece is going to be 2. So SU is 2, which makes the entire RU 6. And it has similar relationships. So continue down the line, RW, that's total of 12. TS, if TS, I don't have TS anywhere on here, but I am given RS, VW, and TV. Oh, I have TV. So TV, this whole segment is 9, so I have to split that into thirds. So if I divide by 3, this is the 1/3 piece, that's 9, and I double it, that's 6. So TS is 6, and SV is 3. So we're just dealing with thirds here. We have a 2/3 piece and a 1/3 piece. You might have to double a piece, you might have to multiply by 3, or divide by 2. Just depends. You have to look at it and see, is it the bigger portion? Does it go from the vertex to the centroid, or from the centroid to the midpoint? And telling the difference between a median and altitude. Is BD an altitude, or a median, or a perpendicular bisector? So, I do know that these two pieces are congruent, so that would be enough to say it connects a vertex. So it is a median. It's definitely a median, because it connects a vertex. Is it an altitude? So does it a vertex meet the opposite side at a right angle? It is an altitude. And is it a perpendicular bisector? Well, it's perpendicular and it's bisector, so perpendicular bisector. It's actually all 3. What about number 16? Do I know this is a midpoint? I don't, so it's not a median. Is it an altitude? Does it meet it at a right angle? And it does not. Is it a perpendicular bisector? I don't even see the perpendicular piece, so it's none of them. Right, moving on to section 5.5. We are just looking at one triangle and seeing what the longest and shortest sides are. So they want us to name the angles. They give us the sides, so sides have relationships with the opposite angles. So since AB is the smallest, angle C is going to be the smallest, and BC is in the middle, so angle A is going to be in the middle. And my largest side is AC, so angle B is going to be the biggest. I also need to do it the opposite way. So if they give me the angles, I need to talk about the sides. So shortest side. So I need to look for the smallest angle, then name the shortest side. RT, middle angle, RS, and largest angle. It's going to go with TS. Alright, and so it's shortest to smallest. They may not give you the third angle. What do? Take the two angles away from 180. So subtract to find that third one. Alright, so you might have to name both the angles and the sides with some missing information. Alright, now, is it possible to construct? So this is where we set up 3 inequalities. So you have 6 plus 10. Is that greater than 15? It is. That works. 6 plus 15. Is that greater than 10? Definitely. And 10 plus 15. is that greater than 6? And that is. So because I've got 3 check marks, this is a yes. If you have even one, no. So 11 plus 16, is that greater than 32? That's 27. So this is not. That doesn't work out. So this one is no. And then one like, let's do number 16. So I don't know my third side that it asks for. So I just set up the inequalities anyways. I know that it has to be greater than x. And 3 plus x has to be greater than 8. And 8 plus x has to be greater than 3. So I saw for x both ways. So 11 has to be greater than x. Here I subtract 3. So x has to be greater than 5. And I subtract 8. X has to be greater than negative 5. If it's greater than 5, it will be greater than negative 5. So I'm just going to ignore that piece. So x for this problem has to be between 5 and 11 in order for it to be a triangle. So set up the inequalities. And here you would set up the inequalities the exact same way, but instead of just a plain x, you would have a 2x plus 2 in its place. So you would just have an extra step or two. Lastly, in section 5.6, we're just comparing some sides here. So because we have 2 sides are congruent, so we need to have that. It's the hinge theorem. So I need to have 2 congruent sides in order to compare. If I don't have that, I cannot compare. So 110 degrees means that DE is going to be the bigger side. So I want my alligator eating the bigger side and ignoring AB. So it's going to be less than. Alright, these 2 angles are congruent, so that means their sides are going to be equal. And angle 1, the opposite side is smaller, so it's going to be less than. These 2 are equal since their sides are equal. Since these angles, alright, are not equal, 95 is smaller, so MS is going to be smaller again. And let's see here, angle 1, the side opposite angle 1 is bigger, so it's going to be greater than. Angle 1 is going to be bigger. Alright, so those are a couple of problems. And here we had matching, so it's a similar situation. Alright, so if you guys have any questions on Chapter 5, please feel free to stop in the morning and ask questions. Good luck studying.